question 15 kind of got cut off a wee bit towards the end there, I was running out of time. But yeah, my main point was always do this positive. Sometimes that'll be your first answer, but if you've got a negative number here, you do the positive of this to get the theta, and then you see where your negative answers are going to be, and then use that theta with these equations. Okay, so just to kind of finish that off, you should really watch these as part of like a playlist and see all the videos, because I certainly record them in a one sometimes. So they are linked a little bit. All right, but yeah, sorry we cut off there. And again, if you get any questions, any problems, just leave a comment or something, and I'll try and get back to everybody. So yeah, question 15. This perfume bottle has a label in the shape of part of a circle. Now, again, if I've done any videos with me before, you know the minute we see circles with bits cut off, what we should be thinking about. Okay, all right. So just part of a circle, alarm bell should be going off. All right. Oh, look at this. The diagram of the label is shown below. Now they've really spoon-fed you this. That is incredible. Okay. So center is 0. We know that. AB, that's on the diagram. Radius is 6, 6. Find the height of the label. So I'll tell you what, that's incredible they've given you all this. In other questions gone by, they will have given you this. Maybe they'll have labelled something up. They certainly would have given you that. They would have maybe just told you 9. That is very interesting. Oh well. Pardon me. That's pretty. That's going to help. So this should definitely send alarm bells. You should be thinking, I know how to do this easily. But part of a circle, you're always going to be identifying a right angle triangle, okay, and then solving. Okay, so we always draw a line from the center to the center of the chord here, and that forms a little right angle, yeah. And now we know a right angle we can do Pythagoras. So that whole length is 9, then I know this length is going to be 4.5, okay. The radius here, yep, is 6.6. That's fine. So that's the key to these questions. The minute you see a part of a circle missing, you're always going to be doing a Pythagoras. The radius is from the circumference to the center. They usually give you the chord, or maybe they give you the height, but you're going to be working out one of these lengths. You know, either this or this. All right. And the very last part, to get the height of the label, once we work out this value, let's call it x, you know, the height of this right angle triangle, we're just going to add on this value, which is obviously r, isn't it? Center to the edge, that's r. I mean, for 4 marks at the end, that's fantastic, fantastic. So let's see, what is x then? Well, it's Pythagoras. We're trying to work out a shorter side, so it's going to be Pythagoras take away. Okay, so it's the square root r squared minus 4.5 squared. Okay, so just a quick reminder, if we've got a right angle triangle, the longest side is always opposite the 90 degrees. That's the hypotenuse. Okay, now a squared, b squared, or the two shorter sides, let's just call the hypotenuse c, okay, and that's c squared. A squared plus b squared always gives you c squared. So I have to say that the sum of the squares of the two shorter sides equals the square of the longer side. And then you just manipulate that if you want to work out a shorter side. So say I want to work out a, well I would just say, well, a squared is equal to c squared minus b squared. So then a is equal to the square root of c squared minus b squared. Okay, that's all I've done here. Okay. So what is our r? Our r is 6.6. So calculators out. Let's see, just pause that. Okay, so 6.6 squared minus 4.5 squared, square root, that's going to give me 4.8 upon 3 centimeters. All right, so I'm not sure if that's right just now, I don't know, but what I do know is it's sensible. Okay, I know that the hypotenuse is 6.6, so it can't be bigger than that. The big mistake people make is they forget to do the square root, and they might end up with a massive number in here. You know, it'd be like 18 or something like that. Okay, a big number. That would not make any real sense because it's bigger than the hypotenuse. Okay, so just think about that when you're doing it to begin with. So I've done I've solved this kind of diagram, if you like, for x. I now need to work out the height. So the height is going to be 6.6 plus 4.83. Okay. I know it's a calculator paper, but I'm just going to do this anyway. 14 and 11. Just to remind you, when you do your adds for decimals, you need to keep decimal point in the same place. Okay, and then just our units, centimeters. Okay, so not a lot to that at all because they basically gave you the diagram. Without the diagram, this becomes a, ooh, what am I doing? Okay, but they've given you that. That should be very obvious. And they don't always give you that. Okay. So you get a mark for working out your right angle triangle, just kind of labeling it up as I've done in here. You get a mark for this equation, you get a mark for solving that equation, and then a mark for your final answer down here. Okay, that's incredible. So it's basically 3 marks for Pythagoras, and then just remember to add the radius at the end. 4 marks, brilliant, absolutely brilliant. So again, we've gone through some questions where it's been easy marks. Like I said before, a wee bit of thinking involved there. But fractions not tricky. Rearranging, I think that's that tricky. Similar shapes, not very many variations they can do on that one, is there? Indices, completing the square. There's been some pretty. When you actually break it down and look at what the syllabus is, there's not a huge amount of trickiness in here. There's not a lot of problem solving actually. All right. So yeah, and I think when you go through these, you have to identify how to answer the question as well. So okay. Question 16, very last question. All right. So in the diagram below, let's see, we've got D and E is perpendicular to AC. D and E is perpendicular to AC. Okay, so all that means is that's 90 degrees. Okay. AD is 4, that's shown. BD is 6, that's shown. And AE is the same as EC, that's shown. Okay, cool. Calculate the length BC, X. Give your answer to 1 decimal place. Okay, so we've got 2 points. Calculate the length into 1 decimal place. Right, now let's have a think. What have we got here then? So if I wanted to work out this, maybe I would just look at one massive triangle. Let's have a think. So what if I said this is the big triangle? Okay, and I know that's 6, I know that's 10, and that's X. So 3 sides, yeah, I could do the cosine rule, because whenever I see 3 sides, I always think cosine rule. Okay, but I would need to know this angle in here to do the cosine rule. Can I do that? Well, this triangle in here, I know 2 sides. Does that mean I could work out the angle? Absolutely, yeah. So there's 2 parts to this question. First part is working out this angle. I mean, there's probably a few ways to do it actually, but yeah, working out this angle and then using cosine rule to solve for x. Okay, so let's start with that smaller triangle in there. Okay, so I've got 3 and I've got 4. I'm going to call that x. So I know the adjacent, I know the hypotenuse. Okay, so katoa. Yep, ka. Okay, so it's going to be cos x. I'm sorry, I will get better at writing. I'm so sorry. Cos x is equal to the adjacent over the hypotenuse, which is equal to 3 over 4. Okay, so x is equal to the inverse of cos to the minus 1, shift cos, whatever you want to call it, 3 over 4. That's going to give me 41.4 degrees. Okay, so we're off to a good start. I think we've got an angle in there. That's good. Again, we know 90 degrees is in there, so we actually, if we wanted to, we could work out this angle, and then with that angle, we could use the 180 rule to work out that angle. So yeah, I'm thinking it's not an angle chasing question, right? I think what I've thought of is okay. Again, right? Say you identified this as a cosine question, but you didn't know how to work out that angle. Just make one up. If you couldn't put it together, this was what to do. Just make up an angle. Okay, and work through the rest of the question. Never give up. Never leave marks on the table. Especially a 4 marker. There's definitely marks to be had for going through. Okay, so say you never knew what the angle was in there. I would look at that and I would have just guessed 45. Okay, it looks like that kind of number, doesn't it? Yeah, it's 90. Yeah. Okay, so it looks about half of 90, doesn't it? If you draw a straight line up there, I'd say that looks like 45. That looks like 45. Okay, so we weren't far off, right? So 41.4. So then I would say, oh, I can't remember my cosine equation. It's too hard. Well, they give you, okay, it's right to the front of your paper. All right, so again, just scroll right to the beginning of your paper, and then what's your cosine? So cosine equation. I'm also quite bad for remembering these things. I'm just going to skip to the front as well. This is right to the very front. There it is there. Now we're going to do a length, so we're going to do that equation. A squared equals b squared plus c squared minus 2bc cos A. Okay? Okay, so I've just kind of skipped down to write the equation out because I'm running out of time a little bit. Okay, so b squared plus c squared minus 2bc cos A. Now, with this equation, the only thing you have to remember is the a's. Like before, the a's are opposite each other. Okay, and that's why it was this angle that I was picking out as well. Okay, as long as you use this as your small a and this is your big A, you're going to be fine. This can be B or C, this can be B or C. But the point when you do this or any of the other equations is that you follow that convention that we talked about. Okay, so A, B, and C. Well, what's opposite A? That's big A. Okay, what's opposite B? That's big B. What's opposite C? That's big C. Okay, so just make sure you follow that convention. So if you were to use, say we knew what this angle in here was, if you use that angle for the A, and called this the A on the equation. Okay, so say the cos A was that, and that was your A, that'd be wrong. Okay, you need to make sure it's opposites. Okay, so again, just save a bit of time, I'm just going to substitute this in. I'm actually interested to see how that comes out when it's recorded. But anyway, so that's it. Right now, I've just substituted in. Okay, so B and C, B and C. So that means that A squared is going to be equal to calculator. A squared is going to be equal to A squared is equal to 45.99. So maybe just rounded it. It's probably 46 if you did it all in your. I think I just did 100 plus 36 minus. Oh, you know what? It's the 41.4. If you're more accurate with that, you would probably got 46. Okay, and then A is going to be equal to root of that. So that's for me 6.78. Okay, probably if you put this in exactly into your calculator, and if they're more exact with this number, this would have come out probably as 6.8 or something, I think. But yeah, so that for the centimeters. Okay, that's looking good. But don't forget, give the answer to one decimal place. So always leave your answer like this, and then do the rounding. Okay, so to that is then equal to 6.8 centimeters to one decimal place, because we find our place. One decimal place is there. Yep. Find your place, look next door, 5 or greater, add one more. So it's one decimal place, next door is 8, that's bigger than 5, so we round that up to 8. Okay. Sorry if I'm rushing a wee bit, it's just for time. So 6.8. So look, marking scheme, let's just check, just to see if I was right. Yep, cos A of 3/4. So identify cos A in the angle. So yeah, you're getting 1 mark for that. Then you're getting 2, you're getting a second mark for working out, yeah, for substituting correctly. For working out A squared, you have marked for that, and then you get final answer just to go straight to the end there. Okay, but tell you what though, still 3 marks in that out of 4. This does look like there's a lot of information. You might even thought similar shapes with the triangles and things, and there probably is a way actually. I would have thought maybe to imagine, this is 90. If you know this angle, you could work out this angle, and there's probably a way to do something with triangles actually. But yeah, you see 3 lengths cosine rule. So if you just said, well, I'm going to go here, miss out that first bit, and just do cosine rule, 3 marks out of 4. Okay, 75%. Okay, as an A. If you maintain that average all the way through the paper. So, don't give up. Don't look at a question like it's too hard. Have a wee think. They're giving you lengths, they're not giving you an angle. There's 3 lengths, 3 lengths cosine rule. Okay, so try something. All right, and don't give away silly marks like not doing it to one decimal place in units and things. Okay, so I hope that was helpful. Obviously, as I go through it, I'm still learning myself. There's different ways to explain things and different ways to chat through things. So if you think of anything better or something's not very clear, please let me know. This is as much for me as for anyone, just to me to practice kind of go through this. But yeah, just a quick roundup. Cosine rule, Pythagoras, standard trigonometry, simplifying fractions, rearranging equation, similar shapes, indices, complete the square, sine rule, volumes, standard deviation, we got angle chasing, bit of factorizing, some vectors, and then standard maths and percentages. So yeah, straightforward guys, you can do it. Good luck in your exams, and thanks for watching.